Good evening, everyone. Today we are going to study the first chapter from grade 10 science, and the chapter name is Chemical Reactions and Equations. Okay, so I'll explain in detail each and every line because in CBSE it is very important to study each and every line because the question can be framed in any manner from the textbook. So thorough reading of textbook and the knowledge of every topic is very important in CBSE. Okay, grade 10 science. Now, first one, if you see here, it is given that consider the following situations in our daily life. That is, and think what happens when. The first example is given: milk is left at room temperature during summers. Okay, before that, you also should know the meaning of this lesson. Chemical reactions. In class 7 and 8, we have already studied about physical changes and chemical changes. Okay, so what is a physical change and what is a chemical change? I'll just briefly tell you. If any, in any chemical reaction or in any reaction, if new substances are formed, that is called a chemical reaction happened. If in physical reaction is nothing, but in any chemical reaction, if no new substances are formed, that will be considered as the physical reaction. Okay, so chemical reaction means in any chemical reaction when new substances are formed, and also the equation. So first, before going to study any chapter, we should know the meaning of the lesson. Okay, so according to the current the present to 23-24 exam board exam, total 6 marks is being asked from this chapter. Okay, so this is the weightage of the lesson. This is what you should remember. Now also, so first example is given: milk is left at room temperature during summers. So what happens when when the milk is left at the room temperature during summer? So one thing you should remember, that the taste will change, right? Taste of the milk changes. The taste changes into sour. Taste changes, or sometimes the milk may spoil also. It may get spoiled. Okay, so taste changes. Second one, in second example, an iron tawa or pan nail is left exposed to humid atmosphere. So what happens? Iron, when any iron materials are exposed, they get rusted, right? So it will get rust. So what will be the answer for the second one? You may also write like in textbook itself. It get rust, or it will get rust. Will get rust. So this will be the answer for second one. Similarly, the third one, grapes get fermented. Fermented. What happens when grapes get fermented? Like another new substance will formed. I'll write that you may also remember. It will get convert into alcohol. This is the what happens when the grapes get fermented. This is the example. Like this is the answer you may remember. Now, fourth one, food is cooked. What happens when the food get cooked? So when the food is get cooked, what happens? The raw food will get be cooked. The raw food will get cooked. This is what happens when when the food is cooked, the raw food. Okay, and another example is asking, food get digested in our body. What happens when food get digested? Again, another new substances will form. Actually, this is an example we are going to study in the next topic. This is an example of decomposition reaction. We are going to study types of reactions. So you just remember, when food get digested in our body, it is an example of decomposition reaction. So what happens? So suppose if you take food is considered as a whole, one single. So compound, a single compound breaks into simpler, okay, simpler elements or simpler molecules. You may also remember like this, simpler molecules. So what is a compound again? Okay, compound and the molecule, atom, okay, element, everything already we have studied. We have learned in grade 9. Okay. So here also this is another new substance is getting formed in this example when food get digested in our body. This is also an example of chemical reaction. And next one is when we respire, okay, when we take breathe. So what happened? This is also another example of chemical reaction. See, I'm writing here when we respire. So new substances will form like carbon dioxide, carbon dioxide CO2, carbon dioxide and water H2O, water form. Okay, water water are formed. This is what you should remember. Okay, understood. So these are the examples. Just once again, I'll brief it. So when milk is left at room temperature, what happened? Taste changes. When iron material is exposed to humid temperature or humid atmosphere, they get rusted. Example of chemical reaction. Grapes get fermented. It converts into alcohol. Formation of new substances. Are the color changes? Yes or no? The grapes, when they are in green color, when it get fermented, change into dark brown or black color. Color changed. Food is cooked. When food is cooked, raw material, when hard substances become soft. Again, chemical reaction. Food get digested. Food get digested. Suppose food. Imagine this is a food. When it get digested, it will break down into simple molecules or when simple compounds. Like what is happening when we eat food, when it enters into our stomach, the food get digested. It get divided into small particles. It's called. It is also an example of formation of new substances. So it is also an example of chemical reaction. And next, when we take breathe, when we respire, new substances will form like carbon dioxide and water are formed. This is also formation of new substances. So all these are examples of chemical reactions which has happened. Okay, so these are the points that you should remember from this page, the first page. Next one, in all above situations, the nature and identity of the initial substances have somewhat changed. Yes. So what happened? See, suppose if you take any one example, iron substance, it looks very shiny, right? When it get before it get rusted, it looks very shiny. So that was the initial stage. That is the initial stage of the substance. But what is happening now? So after some time or after some few months, okay, or few days, what is happening? The identity of initial substance. Initial means the starting at the beginning, how it looks at the beginning, how it was. Now what happened after some time? It get changed. So that is what he's saying. Now we have already learned about physical and chemical changes of matter in our previous classes. Yes, we have already studied about physical change and chemical changes. So what is a physical change? In any change, if no new substances are formed, no new substances are formed, that is an example of if no new substances formed, no new substances formed, okay, formed in a reaction, that is an example of physical change. Okay, that is an example of physical change. And suppose if new substances formed in any change, in any reaction, any reaction, well, new substances, new substances formed is known as an form. It is an example of chemical changes. Okay, so these are the definition that you should remember about physical change and chemical change. I hope you understood, right? Fine. Now, next one is whenever a chemical change occurs, he's saying that whenever a chemical change occurs, we can say that chemical reaction has taken place. So chemical change occur. What happened when grapes get fermented? What happened? The color changes, the taste changes. When milk get exposed in here summer, the taste changes. Okay, so all these are the examples of chemical changes, and we may say that chemical reaction has taken place. Because of that chemical reaction only, we could see all the changes which have happened in these examples. Now, you may perhaps be wondering as to what is actually meant by a chemical reaction. So, what is a chemical reaction? How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer for these questions. So, he is saying that let us do some activities so that we can understand the chemical reaction in a better way. So as you all could see, the one activity 1.1 is given here. Okay, so activity 1.1 is being given. That is what you should remember. And one more point, uh, the the uh, the video, this video, the activity video has been given in the description. The link has been given in the description. You may watch after this, after the explanation. Okay, so that will give you a clear understanding, better understanding about the chemical reaction. Okay, which is taking place. Now, fine. Now here he's saying that. Uh, Caution means he's giving the suggestion. Okay, so teacher assistance is must, because so here you could see that we are burning the magnesium ribbon. So when we burn the magnesium ribbon, heat produces. So in any chemical reaction, when heat comes, heat releases. That is an example of exothermic reaction that you should remember. So this example, this activity is all about exothermic reaction, and also we see that a new substances will form. We are going to study in this reaction is new substances forms. So let us see what happens actually. What, and before going to do this activity, what are the materials required? First one, uh, take a magnesium ribbon is required. Okay, magnesium ribbon. So I will in that video you will also understand that you will see what is a magnesium ribbon. Okay, and why should we clean it? He's saying that clean a magnesium ribbon about 3 to 4 centimeter long by rubbing it with sandpaper. So what is a sandpaper? That is also you will see here. So he's saying that first we should rub it. Why? Why should we clean it? Why should we rub it? So because magnesium is a metal, right? So when it is exposed to air, the magnesium oxide layer forms on the ribbon, magnesium ribbon. So what happens, suppose if you do not clean it, if you do not rub it with the sandpaper, if you try to burn it, it takes more time. It takes more time to get burned, and you will also not get the proper chemical reactions. For that reason, we need to rub it, we need to clean it. Okay, and with by using sandpaper, it is a rough paper. Okay, it would be rough, and whenever you use the sandpaper, it automatically removes the magnesium oxide, the layer magnesium oxide which is formed above the magnesium ribbon. Next one, hold it with pair of tongs. So these are the pair of tongs. Okay, so whenever we are doing any activity using the fire or burners, candle, so we must use the tongs. Okay, and burn it using a spirit lamp or burner, and collect the ash so formed in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it away as far as possible from ice. So what do you observe? So he's asking. So actually magnesium ribbon is a metal. Okay, and before going to do this activity, what I need? I need a magnesium ribbon, I need a pair of tongs, I need a burner, I need a watch glass. Okay, and now these are the minimum materials. So when I rub it, so first thing I should rub it. After rubbing it using the pair of tongs, one end I'll hold it, and then another end I'll burn it. Okay, so what happens when we burn it? When we burn the magnesium ribbon, see here, what happens? He's asking, what do you observe? So what do you observe? Tell me. Any idea? No, we do not get any idea because we did not do the activity. So when we do the activity, so what do we observe? That I am going to write here. So you also please note down the same here, because you have the space provided. You note down whatever the changes we observe. So what happens is, so I'm writing the answer, when magnesium, okay, magnesium, I'm writing symbol also, M capital, G small, okay, magnesium is the chemical symbol, okay, of element magnesium. Magnesium ribbon, okay, magnesium ribbon burns with dazzling, dazzling means a bright, okay, dazzling white light. It gives a dazzling white light. And what happens? And also after that, that magnesium ribbon, the metal, it gives it or it converts into a white powder. Okay, it converts into a white powder, and that white powder is called as magnesium oxide. Okay, what is it? What is that? It is magnesium oxide. I'll write the formula M capital, G and O capital. This is the magnesium oxide. And where do we need to, okay, so these are the observations. Okay, understood? First one, when the magnesium ribbon burns, what happens? It gives the dazzling white light. Dazzling means very bright, very shiny white light. And second one, you can also note down here. Second, it converts into a white powder, which is called as magnesium oxide. And what is the what we do after that? So here in this diagram, you could see that that white powder is being collected into a watch glass. Now, one more point you can add. One more point you also remember, because it will also help you. Now that magnesium oxide, is it a basic in nature or acidic in nature? That you have to remember. So how will we understand, or how do we know that whether it is a acidic or basic? By using the litmus papers, right? So we have red litmus paper and blue litmus paper. So everything is being explained in the video detail. The video link will be given in the description. Okay, so please watch the video. So actually, this magnesium oxide is basic in nature. Is basic in nature. So how come we do? Because we are doing the activity. So watch the video, then you'll understand. Okay. So magnesium oxide powder is basic in nature. So these are the 3 points you should remember. Okay, for this whole page. So if you remember, if you do your practice also according to the page wise, then that will help you to give you to score uh, a good marks in your science exam. Okay, so let me brief once again this page. Okay, fine. So from this page, how many questions can be asked? See, sometimes he may give you the diagram and he may ask you, what is this? Okay, here it is mentioned magnesium oxide. If we just put the dash here, so he may ask you, what is this? This is called magnesium oxide. And here also it may be asked, so in this activity what do you observe? So then you need to write these 3 points. So this may be asked for 2 marks. Sometimes it may be given in MCQs, because it is already asked in the previous board exam. MCQs. Okay, and what is the color of magnesium oxide? Very, very important. The magnesium, the powder color is in white. And what happens when magnesium ribbon is burned? It gives the dazzling effect. It gives dazzling effect, dazzling light, or dazzling, not effect, actually dazzling flame. Okay, a bright color. So these are the points. And okay, so and one more very, very important point that I'll tell you. Now sometimes he may ask you, okay, he may ask you to write the chemical equation for this reaction. Understood? Chemical, write the, see, I'll use one more color. Question, how the question can be framed. Write the chemical equation for this reaction. So which reaction it is? Burning of magnesium ribbon and converting it into magnesium oxide. So to do this, what is important? Okay, very, very important one. Gas is also which also help us. Which gas it is? Oxygen gas. So what happens? Magnesium ribbon, okay, Mg plus oxygen. Oxygen is required, right? Combustion. It's studied in combustion and flame. Okay, so oxygen, chemical formula O2. Okay, O2, O2 magnesium plus oxygen gives rise to magnesium oxide. M capital, G small, and O, magnesium oxide. Now you check whether it is balanced or not. We are going to study how to balance also, but I am just giving telling you the questions which can be framed in exam. Okay, so now here if you observe in left hand side, okay, these are called reactants. Left hand side are reactants and right hand side are products. And this is an arrow. See, this is the tail of the arrow and this is the head. So head always pointing towards the products. So left side we get reactants. So magnesium is a reactant. Okay. So these are the reactants. And right side products. Right side it is a product is formed. So here we are getting, here we are using how many reactants? Two reactants. So whenever two different substances are we are using, we separate them by using a plus symbol, plus sign. Here how many products we have is formed? Only one product. So we are not using any like any plus symbol. If we get more products, that time we use again plus to separate the products. Okay, this is what you remember. Now if you observe here in left side there are two oxygens, but whereas right side only one oxygen. So what we need to do, we need to balance it. So how to balance? So two oxygens are required, so then I'll put two here. So if I put two here, then how many magnesium? Two magnesium and two oxygen. Here two oxygen, so it is balanced. But what about magnesium? It is not balanced. So what I need to do, again I need to put two here, then it get balanced. Okay, so what I'll do is I'll write the final balanced chemical reaction here. Okay, so Mg, okay, plus O2. So two oxygen atoms. So why do we write two O2? That also we have studied in grade 9. Okay, MgO. So it is not balanced. So I'll keep two here. So now two oxygens and two magnesium. So here it is only one Mg. So I'll put two Mg. Now you count here. Check left side two magnesium, right side two magnesium atoms. Left side two oxygen atoms and right side two oxygen atoms, hence it is balanced. Understood? So this is what you should do your preparation. In this way you need to do the preparation. So I'll just brief it. I'll make the video of the whole chapter, and I'll merge the videos and I'll put upload in the YouTube. This is just for the clear understanding how the question, how we need to do our revision, how we need to do our practice for exam, and how we have to study, in which way, what is the procedure to study, in what way we need to study and remember, because every sentence is very very important for CBSE board exam. So what we have studied in this, so first we have understood the meaning of chemical reactions, and here few examples are given. So I have already also explained what happens when these changes happen. So we have seen that in some chemical reactions color is changed, in something like energy is produced, in some chemical reactions heat releases, in some chemical reaction new substances form. So all these are the examples of chemical reactions. We say that chemical reaction took place or happened. And also after that, we have studied about this equation, right? This activity 1.1. So activity 1.1 actually tells us about the formation of new substance. New substance is formed, right? So it is a chemical reaction, and also heat produces. So this is an exothermic reaction. In any chemical reaction, it heat produces. That is an example of exothermic reaction also. Exothermic reaction. And not only exothermic, we study about decomposition reaction also. That also comes under, this activity comes under that. Okay, decomposition reaction. Okay. So, and what are the materials required for this activity? Magnesium ribbon, tongs, burner, watch glass. Okay, and also sandpaper. So first what we need to do, we need to take a sandpaper and rub the magnesium ribbon of 3 to this. Actually it looks like a ring. Okay, magnesium ribbon, that we need to cut it with the scissors, and then rub it with the sandpaper of 3 to 4 centimeter long. After that, hold it with the tongs and bring it near the burner, so that magnesium ribbon burns and gives a white dazzling flame. Okay, that is that we see the color. And also after that, this metal turns into a powder, and this powder is called as magnesium oxide. So what is the chemical formula of magnesium oxide? MgO. Okay, magnesium oxide. And also this is whether it is acidic or basic. It is basic. How basic, how we come to know? By using a litmus paper, red litmus paper, we use it. And how also that activity also, it is explained in the video. Please watch the video. Okay, and after that what is the color of magnesium oxide? White. Okay, and also you should remember the chemical equation for this reaction. So what are we taking here? Magnesium, and in the presence of oxygen, it gives magnesium oxide. So this is a chemical reaction, but it's not balanced. Okay, so we need to balance it. So here two oxygen, one oxygen. So you put two here. So 2 mg, two oxygen. Two oxygen, only 1 mg, and put one more 2 here. So now it is balanced. So these are the points that you need to remember you in this chemical reaction. Okay, and also this is about first page only, and here it is already given. So this is all about equation activity 1.1. You must have observed that magnesium ribbon burns with a dazzling white flame and changes into white powder, and this white powder is called magnesium oxide. Okay, it is formed due to the reaction between magnesium and oxygen present in the air. Okay, I hope you have understood the video, and watch the activity video also, in which the video link has been given in the description. Okay, fine. I'll make the video of this whole chapter. Okay, thank you so much. Yeah, hello everyone. So in this video, we are going to study activity 1.2, activity 1.3, and also about chemical equations. So in the previous video, that is the part 1, I have explained you about activity 1.1 and the first page, and also the video of this activity 1.1, burning magnesium ribbon and obtaining magnesium oxide in a watch glass. This video I had also uploaded in the channel. Okay, so please do watch it. Then after that, now let us study the next topic. The next topic is about activity 1.2. So first you should remember one point, that activity in activity 1.2, this is actually in this reaction, in this activity, color changes. Okay, so in this activity 1.2, we observe 2 points. One is the color changes, and which color? Yellow color, that also I'll explain. And second one, it is also known as the precipitation reaction. Why precipitation? What is precipitation? That everything you will understand now. So activity 1.2, in activity 1.2, you are going to study 2 points. You should remember 2 points. One is the color changes, and also a precipitate will form in this reaction. So for this activity, so what are the required materials are required substances? One is, take lead nitrate solution in a test tube. So solution means, in any chemical reaction, whenever he says about solution, it means it is dissolved in the water or it is added in the water. Actually, lead nitrate will be in white color. Okay, it is actually in solid state, which is in, it is a white salt. Okay, okay, fine. So what I'll do is, I'll take some amount of lead nitrate. Okay, just imagine this activity also, the video will be uploaded. You may watch it later. Okay, fine. Now I just imagine, I took a test tube and I have added uh, water in it. Then I took lead nitrate and I'll add lead nitrate salt in this test tube. Fine. So that is what he's saying. Take lead nitrate solution in a test tube. Okay. First I took lead nitrate. I'll write the formula also of lead nitrate. Okay. So in grade 9 we have studied about crisscross method, right? So now I'm not going to explain you that, but you remember the formula of lead nitrate. So lead nitrate is, the lead is actually lead 2 nitrate. So lead Pb. Okay. So Pb NO3. Okay. Nitrate 3 2. This is the chemical formula of lead nitrate. Okay, PbNO3 2 in the parenthesis. Okay, fine. Now what I am doing is, I took lead nitrate. This is the first thing, and secondly, after this, add potassium iodide solution to this. So what I do is, I take one more test tube, and now again I'll add this potassium iodide. Potassium chemical symbol is K, okay, capital K, and iodide capital I, potassium iodide. So now this potassium iodide salt, okay, it is also in white color. I will add it in another test tube, okay, test tube number 2. Now both salts are dissolved in the water, right? Okay, so then we call it as a solution. Fine. Now what I am doing? Add potassium iodide solution to this. To which one? To first one. So we took, so plus potassium Ki. So what happens when we do this? Okay, so in this reaction, what happens is when we add lead nitrate solution and potassium iodide solution in one common test tube or one single test tube, you will get lead Pb, lead iodide Pbi2. Okay, so this I2, PbI2, actually first, whenever you mix it, see these two are reactants, okay, left side I told you yesterday, reactants. When we mix these two solution, the color which forms is yellow, okay, so that you should remember. So color changes to yellow color. Then after that, so what happens? So this lead iodide is a precipitate which will settle at the bottom of the test tube. So it is in solid state. So lead iodide is a solid state which settle at the bottom. So we call it as a precipitate. Plus, okay, so lead is, see here, lead and iodide. Done. Now what are the remaining? The remaining is potassium nitrate. So remaining I'll write here. So potassium KNO3, and this potassium nitrate will be soluble. This will be soluble in the water. It is soluble in the water. Understood? Clear? Fine. Now, so now you observe here. So what happens when lead nitrate and potassium iodide will be added, or these two solution, if you add, color changes. So which color? Yellow color. Okay. And what happens? And along with that, potassium iodide, the precipitate, which will be settled at the bottom in solid state. So this is what we observe. We observe in this activity 1.2. So activity 1.2 is which type of reaction? Precipitation reaction. And what about the color? Color also changes into yellow color. Okay, so that you should write in your observation. So what will you write? What do you observe? So what will be the answer? See, here is asking the question. He is asking a question. So the answer will be the color. The color becomes yellow, because why it becomes yellow? Because yellow yellow precipitate of lead iodide deposit on the bottom of the test tube, on the bottom of test tube. This is the answer for your observation. So what happens when lead nitrate and potassium iodide is mixed? Color becomes yellow. So color, because yellow precipitate, which is in yellow color, that lead iodide PbI2. So that is in yellow color, and that is a precipitate which deposit at the deposit at the bottom of the test tube. Okay, so whenever a precipitate form, arrow will be down. If it is gas, arrow up. Okay, understood? Fine. Now, so activity 1.2 is a precipitation reaction. So you please write the same points in your textbook as well and note down the points. Okay, fine. Now let us study about activity 1.3. So activity 1.3 is actually the exothermic reaction. Okay, so you should remember what is activity 1.3, what we are going to study. Exothermic reaction. So what is an exothermic reaction again? So in any chemical reaction, in any chemical reaction, if heat is liberated means if heat comes out of it, okay, heat is liberated, that is called exit, right? Exit means out. So heat comes out of it, heat is liberated out, then that is the exothermic reaction. If heat absorbed, that is endothermic reaction that we study. That also we are going to learn. Okay, so it is exothermic reaction. That is the first point, activity 1.3. And also one more point you should remember, that in this reaction, temperature increases. So these 2 points you should remember for which activity? Activity 1.3. So activity 1.3 is the exothermic reaction, and also in this reaction temperature increases. So let me explain you what are the substances or materials required. First he is asking, take few zinc granules. So zinc granules are the metals. Okay, zinc is a metal, right? So in a conical flask. Now I took in a conical flask or a test tube. Even you may take in test tube also. So add dilute hydrochloric acid or sulfuric acid. So what is the formula of hydrochloric acid? I'll write here. So HCl. Okay, and sulfuric acid H2, sulfuric acid H2SO4, S capital O capital 4. Okay, so H capital and the subscript. Okay, 4. Fine. Now what is he saying? He's saying, see, this is a concentric, these two are the concentric acids. So what we need to do, we need to dilute. So there is a process, dilute. I'll give you the trick also. See, in alphabets, the first letter comes is A. Okay, acid. So just remember, A stands for acid, and after that W. So W stands for water. So what I'll do, to dilute acid, acid A2W means acid should be added into the water. Okay, so A2W. So A stands for acid and W water. So acid should be added to the water, and that to how? Drop by drop and drop by drop. Okay, using the dropper, and that too by touching uh, the surface or the sides of the beaker. This is how you should add the process to add acid into the water. So acid to be added to the water, not water to acid. Okay, this trick you can remember. A alphabet A, letter A first. So acid, A stands for, then W. So A to W, it means acid to water, acid to be added into the water. This is the procedure to dilute. Now what I will do, dilute. So either you may take HCl, diluted HCl, okay, diluted hydrochloric acid or diluted sulfuric acid. Fine. Now, so first I took zinc granules, few metal zinc granules in a test tube. Okay, just let us imagine that I took in a test tube. Okay, test tube zinc granules, and then after that I'm adding slowly drop by drop dilute HCl or dilute H2SO4 sulfuric acid. Now what is he is giving the caution, saying that handle the acid with care. Yeah, teacher assistance is must. Now, do you observe anything happening around the zinc granules? This video also I'll upload. Okay. So what is he asking? Do you observe anything happening around the zinc granules? Yes. Yes. What happens around the zinc granules? We observe the bubbles. Okay. So you may write down the answer for this one in your textbook. So yes, I'm writing. Okay. Bubbles seen around zinc granules. Around zinc granules. After some time, zinc granules due to why the bubble form, because the granules, because H2, what happened, hydrogen gas, H2 gas, because hydrogen gas liberated is liberated because you are adding HCl. So HCl, dilute HCl or diluted H2SO4 sulfuric acid. So in both the acids we have hydrogen in it, so hydrogen gas comes out of it or liberates. Okay, now, okay, that is the answer for this one. Okay, this question. And now after that he is saying, touch the conical flask or test tube. Is there any change in temperature? Yes, yes, definitely. So what changes? You may write the answer. Yes, temperature, temperature, or you feel warm. Okay, you feel warm. Temperature. Why we feel warm? Because temperature increases. So in any chemical reaction, if temperature increases or heat comes out of it, what type of reaction it is? You may also remember that it is exothermic reaction. Okay, clear? So these are the answers for these two questions. Fine. Now you observe here. So what type of a question are according to CBSE board, suppose in CBSE exam, how a question can be framed or asked in this? So maybe he asked to write the balanced chemical equation for what? For lead nitrate and potassium iodide. As I have already explained, but once again I'll write. Okay. So what first we are taking lead nitrate. So Pb formula Pb NO3 parenthesis close NO3 2 plus potassium iodide formula Ki gives rise to. So what happened? Which color forms? Yellow color and precipitate because of potassium iodide PbI2. Okay, PbI2 and arrow down because it is a precipitate. And then the remaining potassium nitrate KNO3, which is dissolved or which is soluble in the water, KNO3. This is the chemical reaction for this activity 1.2. And then activity 1.3. Okay, so sometimes he may ask you to draw this diagram, activity 1.3, or sometimes he may give this diagram including all the parts, and he may ask you which gas is liberated in this activity. So which gas? Hydrogen gas. Or one more question can also be asked, which type of chemical reaction it is? It is a exothermic reaction. Okay, or else sometimes he may ask you what are the materials we took in this activity. So what are the materials? Zinc granules, so dilute sulfuric acid or hydrochloric acid. Now okay, fine, so we have studied 1.3 also, activity 1.3. Now what is the remaining? He may ask you to write the chemical reaction for this chemical equation for this reaction. So what are we taking? Tell me. So we are taking zinc granules. So I'll write Zn, Z capital N small, and it is in which state? So metal, it is a solid state. Okay, plus, and what I'm adding, just let us, he's saying that sulfuric acid. So H2, what is the formula, chemical formula? H2SO4. And which type of acid? What we are doing? We are diluting it, right? So H2, S capital, O capital, 4, and it is diluted or it is dissolved in water. So whenever it is dissolved in water, we write aqueous. Okay. So what happens? So you will get zinc sulfate salt. So I'll write hydrogen gas is liberated now. So first you write plus H2. Okay. Plus H2. So, and this is gas, right? So gas means arrow up, precipitate down. So hydrogen I have written, and what is remaining? Remaining zinc, Zn and SO4. So I'll write Z capital, N small, S capital, okay, O capital and 4. So zinc sulfate. And what about this zinc sulfate? Where it is present? It is dissolved in water. So I'll write aqueous, AQ, aqueous. And this is what about H2? It is a gas. So you may write in bracket G. So this is the chemical equation for activity 1.3. Okay. If you take HCl, you write the answer, write the equation and drop the message in the comment box. Okay, fine. Now, I hope you have understood activity 1.2 and 1.3. I have uploaded activity 1.1 video as well. And tomorrow, or in the same video, the two activity videos will be uploaded in the description. Okay, fine. Now, let us study, right? Let us see here. From the above three activities, what are those three activities? 1.1, 1.2, 1.3. We can say that any of the following observation help us to determine whether a chemical reaction has taken place. So in the previous three activities, 1.1, 1.2, 1.3, what is he saying? That you might have observe any change in out of these four. So change in state. So state, right? Yes, this activity if you take, when we have added zinc, around zinc metal, gas is liberated. So state changes. Color also changed, right? In this activity 1.2, color changed to yellow. Evolution of gas. Yes, activity 1.3 is an example of evolution of gas. Which gas is coming out of it? Hydrogen gas. And change in temperature. Yeah, in the same activity, temperature is also changing. So it is an exothermic reaction. So from these three activities, so activity 1.1, 1.2, 1.3, we have seen these four changes occurred, or four changes has happened, right? Now, as we observe the changes around us, we can see that there are large variety of chemical reaction taking place around us. We will study about the various type of chemical reaction and their symbolic representation in this chapter. So now what we are going to study? We are going to study the actual, the main topic of the subject, chemical reactions, and also the representation. How do we represent the chemical reaction? Okay, so the next topic is about chemical equation. So what is a chemical equation? First, before going to study about chemical equation, first you should know the definition of, we should know the definition of chemical equation. So what is the definition of chemical equation? I'll write a written format. Okay, I'm writing the definition. A written representation. Okay, a written representation of chemical reaction, of chemical reaction. So chemical equation. What is a chemical equation? It is a written representation of a chemical reaction. Understood? Fine. Now, after, okay, let me read this paragraph, this paragraph. Activity 1.1 can be described as when a magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. Yes, we know that. We have studied also. This description of a chemical reaction in a sentence form is quite long. Yes. So, suppose if I need to, describe it. So representation spelling, I have written representation SEN. Okay. So what is he saying? To describe it, we need to, I'm here, we need to write the sentence, right? It is too long. It takes some time also. So instead of that, we can write in a short form. So how? So by using the words. See, magnesium, I have written MAGNES. I have written the spelling of the magnesium plus oxygen spelling. Okay, the word, and then magnesium oxide, the product. So left side, whatever you have, they are the reactants, LHS side, left hand side, and right side, product. And in between these two, you will see an arrow. This is a tail and this is head. So head is pointing towards the product and tail is pointing towards the reactants. So let me read this. The substances that undergo chemical change in this reaction 1.1, magnesium and oxygen. So these two substances are undergoing in the chemical change. So they are known as reactants. And after they both get reacted, we are getting a final product. The final substance or a new substance, and that is known as the product. So a word equation change reactants to product through an arrow placed between them. So what is he saying? What he mean to say? He mean to say that, like, in between reactants and product there is an arrow. Okay, so arrow, the head points where? It points towards the, shows towards the product, and tail towards reactants. And now if you observe, here we are taking two reactants. We are using two reactants. So that is the reason I used plus symbol left side. So that is what? Plus sign. And right side, how many products are there? We have obtained only one product. So I am not using any plus. But if we get more than two products, then we separate the products by using plus symbol. This I have already explained yesterday also. Okay, understood now? Fine. This is what he is explaining in this paragraph. Now, writing a chemical equation. So how to write a chemical equation? See, first one is sentence. First he is talking about the sentence. Okay, sentence is quite long. So after sentence, short form, writing the word equation. Again, I have written the word equation. This is also, like, long, right? It is also long when you compare. Now, so what I do, final thing, finally, I try to make them in a very shorter method or short method by using what? Symbols, by using the symbols of a chemical equation. So here what happens then it becomes very small. So instead of that I use a chemical formula symbol. So for magnesium I will use Mg, okay, and for oxygen is a diatomic particle, so I'll write O2 plus magnesium oxide MgO. So this is how we write a chemical equation. So chemical equation will be written by using chemical formula instead of sentences or instead of words. Okay, so we are using chemical formula. So this is a which one? This is activity 1.1. I have already explained in the previous video. Now observe, he is also again saying that count and compare the number of atoms on each element on the left hand side and right hand side. So now he is asking count. So count left hand side atoms. How many? Magnesium, how many atoms we have? One atom. Oxygen, how many atoms? Two atoms. Now you compare right side. Magnesium, how many atoms? One atom. What about oxygen? Oxygen also you have one. So is it balanced? No, it is not balanced. So what you need to do? You need to balance it. So how to balance? So next topic is how to balance. So first what we do is, first the word equation will be written in the form of using chemical like chemical symbol. Okay, fine. So zinc, next activity 1.3. Okay, activity 1. Zinc plus, okay, sulfuric acid, right, H2SO4 gives rise to zinc sulfate. Okay, you write on this. Zn means zinc. Zn, zinc plus, okay, zinc plus what is H2SO4? Sulfuric acid. Sulfuric acid gives rise to what? It gives rise to zinc sulfate. Okay, I'm writing zinc sulfate is a salt. Okay, zinc sulfate plus, and which gas is liberated? Hydrogen gas. Okay, fine. So this is a word equation actually. So word equation is representing by chemical symbols. Okay, fine. Now, if you observe in this chemical reaction, let us see whether it is balanced or not. So right side, see first check left side zinc. Here right side, how many zincs are there? Only one zinc. So zinc is balanced. Now come to hydrogen. Left side, how many hydrogen atoms are there? Two. So right side, two. Now you see sulfur. Sulfur, how many? One left side. And what about right side? One. Now what about oxygen atoms? How many left side? Four. And how many right side? Four. Now is it balanced or not? Yes, it is balanced. So here it is given in the tabular form. So what he did is, in this table, first he has written all the elements. First element zinc, then second hydrogen, then third sulfur, okay, then fourth oxygen. These are the elements which are present in the chemical equation, right? In this chemical equation. Now, so left hand side are called reactants. So first in the second column, second box, number of atoms in reactants. LHS means left hand side. And another column, another box, number of atoms in the products or right hand side. Now what is like just you see here. So zinc, how many left hand side? One. So we have it is written one here. What about right hand side zinc? How many? One. So now you check whether it is balanced left hand side. Yes, it is balanced. Now come to the next atom, hydrogen. How many hydrogen left side? Two. How many hydrogen atoms right side? Two. Is it balanced or not? Yes, balanced. Now go for the next element, sulfur. So sulfur, how many left side? One. And right side? One only. So it is balanced. Now come to next element is oxygen is remain. So oxygen, how many oxygen left side? Four. Right side? Four. Is it balanced or not? Yeah. So this is already a balanced chemical reaction. So it is balanced now. Now coming to the, let us see the next chemical equation. So what is the next chemical equation? It is iron. Okay, iron. One more point you should remember here. Here in 2020, okay, in 2020, sorry, not 2022, I think, in 2020, in CBSE board, there is a question asked for 1 mark. Okay, I'll write the question. You try to solve the answer. The product, okay, the product formed, how the question is framed here. See, the product formed zinc reacts when zinc reacts with sodium hydroxide. Okay, what are the product which is formed when zinc reacts with sodium hydroxide? This is a question asked for 1 mark in where in 2022. 2022 1 mark question. Okay, or it can the question I'll write here. The question zinc Zn plus sodium hydroxide NaOH capital. Okay, gives rise to gives rise to dash. And this is the question asked. Okay, so what will be the answer? Tell me. So it is already given in the textbook also. So the answer in this dash, the answer will be sodium zincate. Okay. So when zinc reacts with sodium hydroxide, so we get, I'm writing the equation here, sodium zincate, Na2. Okay. Using the mouse, so handwriting is not that much clear. Okay. So sodium Na2 is Na2 sodium zincate ZnO2 Na2 ZnO2 sodium zincate will form along with that sodium hydroxide na? So hydrogen gas comes out of it. So now what is this? This is called sodium zincate. So very important chemical equation, sodium zincate plus hydrogen gas. Okay, this is asked for 1 mark, so you should remember it. Okay, sodium zincate was the formula Na2ZnO2. Okay, fine. Now let us go for the next one. Next is iron. So F is ferrum. Okay, so iron. Let us try to balance. He's asking to balance the chemical equation. What he has given? Iron plus water H2O gives rise to ferric oxide Fe3O4 plus hydrogen gas. Now he is asking us to balance it. So there are two methods. Okay, there are once if you practice number of questions, now balancing the equation, then you will understand. You will also like yeah, you'll know how to balance the chemical reaction. Now, first if you observe here, so check left side. So what is the process here? He's asking. First, if you write the elements, all elements. So first one, let me write element iron left side. Okay, and next one hydrogen. Okay, and what is the next element? Oxygen. Anything extra? No, fine, done. I have written all the elements which are present in this chemical equation. Now, first left hand side reactants, left all the reactants left hand side LHS and products right hand side RHS. So these are the products. See now products here reactants are two, so we use the symbol plus to separate the reactants. Now how many products here? Two products. So again we use the symbol plus. Okay, if more number of products are there, we separate by using the symbol sign plus sign. Okay, so Fe how many left side? One. So right side how many Fe's? Three. So is it balanced? No. First let me write all the elements, all the number of atoms which are present left side and right side. Next hydrogen how many left side? Hydrogen two. And how many hydrogen present right side? Two. So hydrogen is balanced. Now coming to oxygen, how many oxygen left side? Oxygen one only. And what about how many oxygens present right side? So there are four oxygens. Now what we need to do? So now we need to balance it, right? So how do you balance? So there are so many methods, right? So if you keep on practicing here, already given step by step. Okay. So I'll directly write the final one. So first I need to see here here I have 3 iron atoms. Here I have 1. So what I do, I'll keep 3 here. Now left hand how many? 3, right? So I'll use another color. Okay, I'll use another color. So here now left hand side 3, and what about right hand side? 3. Fine. Now come to hydrogen. Hydrogen is balanced. You need not to change. Now we need to, like, check for oxygen. We need to balance it. So we should not keep 4 here, right? So this is wrong. So where to keep 4? So we should keep 4 in front of H2. So now you check once again. So left iron how many? Left hand side 3, right hand side 3, balance. Now what about next one, hydrogen? How many hydrogen? You tell me here. Here 2 previously, but when I put 4 here, it has become multiply 2 into 4, 8. Now left hand side hydrogen are 8 atoms. Now what about right hand side? Only 2. So how many you need? 6 we need, right? So I'll keep 4 here. Now you check. 2 4s are 8. Now is it balanced or not? Yes, it is balanced. Now come to the oxygen. Now left side, if you see, 4 oxygen. So how many? 4. Now what about right hand side? Oxygen how many? 4. Now is it balanced or not? Yes. So what will be the final balanced chemical reaction? Chemical equation is 3Fe plus 4H2O, 4H2O, okay, 4H2O gives rise to Fe3O4, ferric oxide Fe3O4, because when iron exposed to water or moisture, it forms a layer, ferric oxide, right? Plus Fe3O4 plus 4H2. This is the final chemical equation, balanced. Now here if you observe, is it balanced previously? No, it is not balanced. So any unbalanced, okay, very very important, any unbalanced chemical equation, unbalanced chemical equation is called as what? Is known as skeletal equation. Understood? An unbalanced chemical equation is known as skeletal equation. So what we have to do, we need to balance the skeletal equation. So when you balance the skeletal equation, it is called balanced chemical equation. So this is how we should balance it. So one more easy method is also there, but now it's not required. So first what you have to do, you should write all the elements. Then after that, number of atoms left hand side, number of atom right hand side, and try to balance the chemical reaction. Then you will get the final balanced chemical reaction. So here in your textbook, he has given, see, the final one. And this is the balanced chemical equation. Balanced. If it is not balanced, it is called as skeletal equation. Okay, fine, understood. So number of atoms on both sides are equal. This equation is now balanced. This method of balancing chemical equation is called heat and trail method. So which method that we have used now to balance? The method is known as heat and trail method. As we make trials to balance the equation. So we make trials, right? By keeping 2 here, left side, right side 2, sometimes left side 4, right side 4. So these are the trials we made. So that is why we call it as the heat and trial method, by using the smallest whole number coefficient. So what is the coefficient here? See, previously 3 was not there. So 3 coefficient I took here. So previously 4 was not there. So I took 4 coefficient. These are the smallest coefficient. Why? To make the chemical equation balanced. Okay, now fine. Now we have written balanced. You made it balanced equation. Skeletal equation, you made it balanced. Now what about the next topic, or what is the next procedure? You need to write the states, physical states also in the brackets. So what are the physical state? Tell me, there are 3 types of states. One is solid state, liquid state, gaseous state. Suppose if it is dissolved in water, then it is aqueous. We write aqueous also. Okay. For precipitate, arrow down. For gas, arrow up. For solid we write in. Now is so after balancing, then we need to write the physical state also. Now tell me iron. Iron is a metal, right? So it will be in solid state. So I have written S here. Now what about H2O? So very important here. Okay, very important. Water is given in which state now here? Gas. Okay, so why sir? Why actually water is should be in liquid state now? Why sir here it is mentioned G? Because here the water H2O indicate that the reaction used or water used in the form of steam. Very important. Underline, please do underline it. So used in the form of steam. That is the reason here water is in the state of gas. So I have used gas here. So I need to mention the physical state also. It is in gaseous state. Gives rise to ferric oxide. Ferric oxide, it is also solid state. So I have put S. Now hydrogen. Hydrogen gas liberated. Na? So gas which letter or which symbol? G. So as it is a gas, so you may put above up arrow also. So I hope you have understood. Okay, you have understood about writing chemical equation using chemical symbols. After that, how to balance. After balancing, so if it is not balanced, it is called skeletal equation. After balancing, we need to write the physical states also. Okay, fine. So and also we need to mention the physical state by using G, L, A, Q, S. Okay, and on so on. And then now you see here sometimes. Okay, sometimes like the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow. So sometimes in any chemical reactions, there are some conditions. There are some conditions which has to be given certain temperature. Okay, which is mandatory. That time those conditions na we will mention above the arrow or below the arrow. So in this here, okay, I'll write here. So what are the what is happening here? You see in this chemical equation, he is taking carbon monoxide, CO. So carbon monoxide. Okay, I'll write. You also note down in your textbook. Carbon monoxide. Mono means one. Monoxide gas, right? Plus H2 means what? Hydrogen gas. Okay, gives rise to what happens when you add carbon monoxide and hydrogen gas. Okay, carbon monoxide gas. So what will you get? You will get methyl alcohol or ethanol. Okay, so we will get methyl alcohol. So now methyl alcohol, which state? Tell me. Liquid state, right? So what happens here? Very important. This is very important chemical reaction. See here, carbon monoxide. We are using both reactants gas. But what is the final product? We should get gas only, right? But here we are getting liquid. How the liquid? Only one condition when you provide or when you give 340 atmospheric pressure. So this is condition. So when 340 atmospheric pressure is being given in this chemical equation, you will get ethyl alcohol in liquid state or liquid form. So this is also one important equation. So this is a condition. Only here you are taking two gases, but product is in liquid state. So that time you need to mention it above the arrow. Next one, if you observe here, another chemical equation, that is carbon dioxide plus water. Carbon dioxide, which carbon dioxide actually it should be gas, right? But it is dissolved. Okay, so aqueous state plus water liquid state. In the presence of sunlight, and chlorophyll, so what do we get? Glucose, C6H12O6, aqueous state, plus oxygen plus water. Okay, oxygen aqueous dissolved state, and water liquid state. So this is all. So see, here we are taking carbon dioxide and water. So what are we getting? We are getting glucose. So this is a photosynthesis process. So plants prepare their food in the presence of sunlight. So sunlight is mandatory. So that is it mandatory. So it is written above the arrow. Okay. So for some chemical equations, the conditions are must. So that time we write above the arrow or below the arrow. Okay. So I hope you understood till here. Any doubts if you have, just comment in the comment box. And now the next topic I'll record in another video. Thank you so much. Yeah, hello everybody. So in the last video, we have studied that the previous topic about how to balance the chemical equations. Okay, and now today in this class, we are going to study about the questions which are given in page number 6. Okay, fine. Now, if you observe here, the first question I'll read. Why should a magnesium ribbon be cleaned before burning in air? This is the first question. Okay, and the video has been already uploaded in the in the same channel, Prashant Physics, so that you can watch and then you will understand better. By now, here the question is, why should a magnesium ribbon be cleaned before burning in air? So the answer, as we all know that magnesium is a metal, right? So when it exposed to oxygen and carbon dioxide, what happens is a layer of a layer of magnesium oxide MgO and magnesium carbonate. What happens, that a layer will form on the magnesium ribbon. Okay, actually it looks like the magnesium ribbon looks like silver color, the white, it is shiny, but because when it is exposed to oxygen and carbon dioxide, it becomes dull color, the color becomes dull, or it becomes the dark color, black color, because of a layer which is formed on the magnesium ribbon, and that layer is known as magnesium oxide or magnesium carbonate. So that is why we should clean before burning in the air. And also one more advantage is it will burn smoothly. Okay, that is the answer for the first one. Second one is write the balanced chemical equation for the following chemical reactions. So what is the first one he is asking here? He is asking write the balance equation for hydrogen. So what is the formula? Hydrogen H2 plus chlorine Cl2 gives rise to hydrogen chloride HCl. So if you observe here chlorine, the reactants left side, there are two atoms of chlorine and two hydrogen atoms. But whereas right side, the products, we have only one hydrogen, one chlorine. So I'll write 2 here, and so that this chemical equation is now balanced. And the second one is he's asking to balance, to write the balanced equation. So barium chloride, the formula for barium chloride is BaCl2. Okay, Ba, B capital, A capital, small letter, C capital, L and 2. Barium chloride plus aluminum sulfate. Okay, the formula is, note down, Al2 SO4 SO4 3. Okay, and gives rise to barium sulfate. Okay, the formula of barium sulfate is Ba BaSO4 plus is there already. Okay, and aluminum chloride. The formula is chloride. Okay, CaLCl3. Now you check whether the equation is balanced or not. So if you see here, we have barium 1 left side and right side also 1. So it is balanced. Now, what about chlorine here? How many chlorine do you have? You have two, but whereas here you have three. So you need to balance it. So how to balance it? What I'll do is I'll write 3 here. So if I write 3 here, now barium has become 3. Okay, so I'll put one more 3 here. Now barium is balanced. Now, what about chlorine? See, 2 you have 2 chlorine atoms and here 3 and again 3 more. So you need to multiply it. Okay, so 2 3s are 6. So here you have 3. So I'll put 2 here. So 3 2s are 6. It is balanced now. Now coming to aluminum. So aluminum, how many atoms you have? Left side 2 and right side also 2. So it is balanced. Now come to sulfur. Sulfur, how many do you have? You have sulfur 1. Here 1. It is balanced now. Now what about oxygen? Oxygen is 12. Now what about oxygen here? 4 into, okay. So 4 into, sorry, sulfur, how many you have? 3. Okay, here also 3 now. Now fine. Now what about oxygen? So you have 4 into 3, 12. And here also 4 into 3, 12. So it is balanced. Now third one is sodium. Sodium, what is the chemical formula? Sodium Na. I'm writing for the third one plus water. What is the chemical formula of water? H2O. Water gives rise to sodium hydroxide. What is the formula of sodium hydroxide? NaOH plus hydrogen gas H2. Now you check whether it is balanced or not. Sodium 1, sodium 1 balanced. Hydrogen 2, hydrogen, hydrogen 2 there, but here you have 2 and here one more. So now right side you have 3, but left side you have 2 only. So what I do is I'll put here 2. Now how many hydrogen? 2 2s are 4. So here how many you have? Left side 1 only. Here 2. So what I'll do, I'll keep 1 2 here. Now you check once. So sodium how many? 2 right side and here 1 only. So I'll keep 2 here. Now 2 sodiums balance. Oxygen how many? 2 and here 2. It is balanced. Next one hydrogen how many? Here you have 2 and here 2. 2 plus 2 4 and here 2 into 2 4. Now it is balanced. Okay, I hope you understood. So you also note down the balanced chemical equations. Okay. Now, the third question is asking write a balanced chemical equation with state symbols for the with the state symbols for the following reactions. Okay. So now what is he asking? He's asking to write the balanced equation. Okay, with symbols. Okay, very very important with symbols. Okay. Now let us see the first one. Solutions of barium chloride. Okay, solutions of barium chloride. So what is the formula of barium chloride? The formula of barium chloride is BaCl2. BaCl2. Okay, barium chloride. Now he's saying it is a solution. Solution means it is dissolved in water. So that time what we do is we will write in bracket aqueous. Okay, and and sodium sulfate. What is the formula? And means plus sodium sulfate. I am writing here. The formula of sodium sulfate is Na2SO4. Okay, we have studied about how to write a formula in grade 9 only. Okay, there. Here also it is solution, right? So aqueous gives rise to give insoluble barium sulfate means a precipitate is going to be formed. So the formula will be barium sulfate BaSO4. BaSO4 and this is a precipitate, right? So precipitate settle at the bottom and it will be in a solid form. So I'll write S small s in the bracket and one arrow down. Down means it as it will be heavier, so it comes and settle at the bottom of the test tube. And plus solution of sodium chloride. So what is the formula of sodium chloride? NaCl. And it is a solution. So we may write it as aqueous. Okay, so what is the first one? Okay, now you check. Sodium how many? 2. Here 1. Okay, yeah. Barium, how many you have? You have barium, one barium here. Okay, here one barium, and right side also one barium. It is balanced. Now, what about chlorine? Chlorine you have two here, and here you have only one. So, what I do is I'll put two here. Now, what about sodium? Yes, two sodium and two sodium. What about chlorine? Two chlorine and two chlorine balanced. Okay, and now you check sulfur, how many? One, and here also sulfur one. Oxygen four, oxygen four. Barium one, barium one. Chlorine two, chlorine here also two. Okay, I hope you have understood, and this is the balanced chemical equation for the third question. Okay, you please note down. Any doubts if you have, you may just share your doubt in the comment box so that I'll try to clarify all your doubts. Next one is sodium hydroxide solution in water. So whenever it is a solution, it means it is dissolved and mentioned in water. So in water, so we may write as aqueous. Sodium hydroxide, right? So what is the formula of sodium hydroxide? NaOH, and he's saying that it is solution in water. So we may write it as aqueous, okay, aqueous plus with hydrochloric acid. So with hydrochloric acid, you write down HCl, hydrochloric acid HCl, and it is also in the water. So we will write it as aqueous, HCl aqueous. And what is it? The product to produce sodium chloride solution. So what is the formula of sodium chloride? NaCl, and he's saying solution. So we will write it as aqueous in the bracket, and plus and water. So and means plus, and what is the formula of water? H2O. Okay. So now water is in still then liquid state. Now you just check, is it balanced or not? Yes. Sodium left side one, right side one. Chlorine left side one, chlorine right side one. Hydrogen two, hydrogen here you have one only, right? Oh, sorry. Here you have one, and here also you have one. So it is balanced now two. What about oxygen? One oxygen. Here also one oxygen. Okay. So now this is the balanced chemical equations. Okay. Fine. Thank you. Yeah. Hello everyone. In this video, we are going to study about the types of chemical reactions. Okay. So if you observe here, he's saying that it was given in this page that we have learnt in class 9 that during a chemical reaction, atoms of one element do not change into those of another element. So it means, suppose we all know that hydrogen and oxygen, okay, hydrogen plus oxygen gives rise to H2O, right? Water. Here there are two different atoms. Hydrogen atom is different, oxygen is different. And finally we are getting the product is water. Even though it is changed into water, but it contains hydrogen atoms and oxygen atoms. He's saying that this hydrogen will not change as oxygen. It means hydrogen will not disappear or oxygen will not disappear. They will be present in the final compound also, in the final result also. Okay, but we get a new substance. That is what he's saying. Nor do atoms disappear from the mixture or appear from elsewhere. That is what he's saying. That even hydrogen and oxygen both are gases, and finally after reaction we are getting a liquid here. So though we have a liquid, but atoms will not change. Atoms are there. Hydrogen atom is present and oxygen is present. Okay, that is what he meant to say. Okay, it is not balanced. So if you balance it, you will understand. Now, fine. Now, after that, actually, chemical reactions involves in breaking and making of bonds. So, this example. like hydrogen plus oxygen. Okay, hydrogen plus oxygen gives rise to water, H2O. Okay, so this is what he's saying. Oxygen 2, hydrogen 2, then here you keep 4. Okay, now, now if you observe here, he's saying that a chemical reaction involved in breaking and making of bonds. Sometimes it will break the bond between the atoms. Sometimes it make the bond. Here, hydrogen is separate, oxygen is separate. So after that, after reaction, they made the bond. So that is what he's saying. Okay, and a new substance is formed that is called water. So you'll study about types of bonds between atoms in chapter 3 and 4. So chapter 3, okay, in metals and non-metals and carbons compounds that we are going to study, okay, more about the types of bonds between the atoms. Okay, now here there are total 4 types of reactions. Okay, how many? Total 4 types of reactions. So this is the first reaction is known as combination reaction. Okay, the first type of chemical reaction is combination reaction. So let us see, study what is a combination reaction. So first we should you just note it down in your books. Okay, I'll use the alphabets to make you understand this chemical reaction. Okay, so I'm using here two alphabets. One is A plus B gives rise to AB. Okay, so here in place of AB and in place of these alphabets, I'll take the I'll take the atoms, I'll take the elements. Then so that you will understand. So this is the hint to remember this combination reaction. Or you may write like this also. Suppose if I am taking 3 atoms here, A plus B plus C, then the final product will be ABC. So this is called combination reaction. So if I give you the definition of this combination reaction here, so how many alphabets I'm using? Left side, tell me two, right? Okay, two. So suppose if I talk about the definition. So what will be the definition? Tell me here. When, okay, when two or more, or okay, two or more substances and two or more substances. Okay, so what are those substances here? I'll use the elements. Okay, two or more in bracket I'll write two or more elements, are sometimes not only elements, even compounds also, or compounds we study. Okay, we will study in the next topic. Combines. So okay, plus A plus B. So A is one element, B is another element, and they I have used the letter plus. It means combine. They are combining. So what happens after combining to form AB? AB is single, right? Previously left side A is separate, B is separate. I have combined them and then I'm getting a single product. Okay, single product. So such type of reactions is called as combination reactions. Okay, such reactions are known as combination reactions. Suppose if you are taking two or more habitants, so in the next example, A plus B plus C, three substances or three elements I took, and finally I got a product. Okay, as I have already explained. So left side we will be having reactants. Okay, these are the reactants. These are reactants, REA, and Ts. And right side, okay, and right side, it is a these are the products. These are products. Okay, understood? Fine. Now, so to make you understand much better, here there are few activities given. Okay, let us see what is the first activity, activity 1.4. So here is saying that take a small amount of calcium oxide or quicklime. It is also called as quicklime. So calcium oxide it's a powder. Okay, it will be in a white color. Okay, in a beaker. He's saying that take calcium oxide powder in a beaker and then slowly add water to this. So he's saying that slowly add water to this. So what happens when we add water and then he's saying that touch the beaker. So if you do this activity, Okay, so the calcium oxide, if you add in the water and if you touch, you will feel warm. Okay, you will feel it warm. So whenever in any chemical reaction, if heat is released, okay, warmness is nothing but heat is produced, right? Such type of reaction are known as, okay, so such this reaction, okay, you remember uh, formation of slaked lime, okay, such type of reactions are known as exothermic reaction, okay. So what is the exothermic reaction? In any chemical reaction, if heat is liberated or heat is produced in any chemical reaction, those such type of reactions are known as exothermic reaction. So in this reaction, what is happening? Heat is produced, heat is coming out. So this is the example for exothermic reactions. Now what is happening? Now touch the beaker. Do you feel any change in temperature? Yes. You write the answer here. Yes. So what happens? So formation of slaked lime. So slaked lime, okay, the formation of slaked lime by the reaction of calcium oxide with water. So you'll get a paint. Okay, that slaked lime we apply on the walls. Okay, mostly in villages they we use the paints actually, but in villages they use this slaked lime. Okay, slaked lime is produced when we mix calcium oxide or quick lime to the water. Okay, so let us see the chemical reaction here. Okay, the equation which is written calcium oxide. So what is the formula? CaO, calcium oxide. It is in solid state. Okay, it is a powder. It's a solid, it's like it appears like a stone also. So white color stones. Okay, stone is nothing, not that stone. It is if you break it, it will become into powder. Okay, so quicklime, calcium oxide is also known as quicklime plus water. So when we are adding water here, water will be in liquid state and calcium oxide in solid state. So I have mentioned in the brackets. It is mentioned in the brackets. Then what will you get? So this paste is called calcium hydroxide. Okay, so calcium hydroxide, and it is dissolved in water, right? So if it is dissolved in water, we write it aqueous, and it is also known as calcium hydroxide is also known as this calcium hydroxide. Okay, it is given here calcium hydroxide plus heat is produced. So that is the reason it is exothermic reaction. This reaction is which type of reaction? Exothermic. Thermal means heat. Okay, exothermic reaction. So now if you observe here, so what is happening? If you carefully observe, what is we are talking about combination reaction, na? So combination reaction, what is the definition? When two or more elements or products combine to give you a single product. Single product. So here now you observe here calcium and oxygen. It's a compound, right? Okay, compound, and here hydrogen, water. So they are combining each other, and finally we are getting only one substance, one product is called calcium hydroxide. So this is an example of combination reaction. Okay, so it is also given here underlined calcium oxide and water combine to form a single product. So what is that single product? Calcium hydroxide. So such reaction in which single product is formed when two or more reactants get reacted each other is known as combination reaction. I hope you all have understood. Okay, fine. Now next topic. So yes, this is very important. Do you know? Okay, do you know? And one more point also I'll tell you. So a solution of slaked lime produced in the reaction 1.3 is used for whitewashing walls. Okay. So see what do we get slaked lime? How did we get slaked lime? When we add calcium oxide plus water. Okay. So we get the calcium hydroxide. Okay. We get the calcium hydroxide CaOH 2 calcium hydroxide. So this calcium hydroxide is also known as slaked lime. Okay, slaked lime. It looks like a paint, okay? A paint because we are adding water here. So slaked lime. And this slaked lime, where do we use? We use for whitewashing. We use as a paint on the walls. Okay, now let us imagine that we have painted it. We have whitewashed it. Then after that, what happened? This calcium hydroxide, after 2 to 3 days, it reacts slowly with carbon dioxide in air. So we have carbon dioxide in the air. So that carbon dioxide will come and react with this calcium hydroxide paint which we are applying on the walls slowly, and it forms a thin layer of, okay, very very important, thin layer of calcium carbonate. Okay, so thin layer of calcium carbonate on the wall. So what is the formula of calcium carbonate? CaCO3. Calcium carbonate will form. See, calcium hydroxide, when it reacts with carbon dioxide, okay, very very important, when it reacts with carbon dioxide in air, it forms calcium carbonate. And this calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finishing to the walls. So it looks very shiny on the walls, okay, after 2 to 3 days. So it is interesting to note that even the chemical formula of marble is also CaCO3. Very very important, please do underline. Okay, what is the chemical formula of marble? It is also CaCO3, calcium carbonate and marble, it is having same formula. Okay, so chemical equation is given here. So calcium hydroxide, okay, aqueous, because it is dissolved in water, right? And carbon dioxide gas, okay, gas, it gives rise to calcium carbonate, okay, as a white color. It's a layer, okay, it looks like a thin layer, and it is in solid state, solid form. So it is mentioned here, yes, and it also gives, like, plus we get the water which is in liquid state, because here it is aqueous, right? Hydroxide means oxygen and hydrogen both are present here. Okay, and it also gives the water. Okay, fine. Now let us discuss, he's saying that let us discuss some more examples of combination reaction. So see here, carbon and oxygen gives rise to carbon dioxide. Burning of coal. Okay, so burning of coal, so burning requires oxygen, right? So what is happening? How many atoms are like, combining here? Our elements are reacting two and giving single product. So this is an example. And formation of water from hydrogen and oxygen I have already explained. So tell me here, hydrogen H2, okay, hydrogen and oxygen gives rise to 2H2O liquid. So two reactants giving one single product. This is also an example of combination reaction. So in simple language, we say that, okay, this is the definition given. When two or more substances, elements or compounds combine to form a single product, such reactions are known as combination reactions. And also we have seen that in activity 1.4, large amount of it is evolved and the mixture has become warm when we have added water in calcium oxide. Okay, so mixture become warm. So in any chemical reaction in which heat is produced or heat is liberated in the formation of products are known as exothermic chemical reactions. Okay, exothermic means giving heat outside, out. Okay, now other examples of exothermic reactions. Okay, so methane CH4 plus oxygen gives rise to carbon dioxide and water. And now it is very very important. See here, methane gas. Okay, it is a gas. And here oxygen gas. Okay, then carbon dioxide gas. Then here if you observe water, which state? Gas here. So water is in gaseous state. Okay, this is what you should note down. Okay, and then do you know that even the respiration is also an exothermic process? Yes. So you're saying that even respiration, respire, taking oxygen inside and releasing carbon dioxide, that is also an example of exothermic process. Heat will release. So we all know that energy, we need energy to stay alive. We get this energy from the food we eat during digestion. Okay, so what happened during digestion? Food is broken into simple substances, small substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose, and this glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction, so whatever this reaction, what is this reaction? When we eat food, when you eat food, that food is getting divided into simple compounds or simple substances, and this entire whole process is called as, this reaction is called as respiration. And the whole process you study in chapter 6. Chapter 6 is from biology, you study in biological science. Okay, And then, so here if you observe, the reaction is given C6H12O6, very very important. Okay, please you should learn it, practice it many times. Okay, glucose, okay, glucose plus oxygen which is dissolved in the, where it dissolved in the blood, okay, in the cells, also in the cells of our body, and the glucose which is also dissolved in our body. And then what will happen when you, okay, this is what happens when you take this. Okay, so when you take it, what are you going to release outside? Carbon dioxide and water plus energy. So this is also an exothermic process. Okay, next, another example, decomposition of vegetable matter into compost. It is also an example of exothermic. Yes, whenever if your mother have, like, while preparing the food, after that the kitchen waste which is thrown into the dustbin, garbage, or if you are making any compost with it, so that is also, the decomposition also gives heat energy outside. It is also an example of exothermic reaction. So these are the example that you should remember. Okay, so now he is asking, identify the type of reaction taking place in 1.1 activity. He is asking activity, which type of reaction? You tell me whether it is a exothermic reaction or endothermic reaction. So what is activity 1.1? We have burned the magnesium ribbon, right? Burning of a magnesium ribbon. When you burn a magnesium ribbon, you are using heat energy, so it is exact. Of course, it is also exothermic reaction. Okay, so where should you write this one? You should write in the first page. Okay, I'll go to the first page. So this reaction he's asking. So which type of reaction it is? This reaction is also an example of exothermic reaction. Why? Because in this reaction, heat is produced outside, heat is liberated, heat is released. Okay, so that is also another example of exothermic reaction. Next, the next example, okay, page number 8. Okay, fine. So decomposition reaction. Okay, what was the first one? Combination. What I have written? A plus B gives rise to AB. Okay, this is a hint to remember. So what is this? What is this hint? Two reactants, two single reactants, or two compounds gives a single compound, or two elements combine and give a single compound. That is an example of combination reaction. Now decomposition reaction. Decompose means divide, right? Reverse of the first one. AB. Okay, this is a hint for you. AB gives rise to A plus B. Reverse of first reaction combination R, suppose if ABC products. Okay, AB is also product. If a product can also be divided into three reactant, three simple substances, A plus B plus C. This is a hint for decomposition reaction. Okay, so this activity, already a video has been made, and you may check in the description about this video. So what are we going to do in this uh, activity? So let us see. Take 2 grams of ferrous, take 2 grams of ferrous sulfate crystals in a dry boiling tube, and now he's asking, note the color of ferrous sulfate. Okay, what will be the color of ferrous sulfate? The color of the ferrous sulfate, you note down in your textbook, the color of the ferrous sulfate will be in light green color. Okay, green, light greenish color. Video already it will be given in the description. Okay, next, after that, after taking ferrous sulfate crystals, so what is he saying? He's saying that, yeah, now after taking it in the test tube, now heat the boiling tube over the flame or a burner or spirit lamp as shown in figure 1.4. Observe the color. Okay, now he's asking, what, observe the color, what will happen? Okay, what type of a color that you will see. Okay, so we did this activity experiment. Okay, so after heating, that light greenish color will get changed into brownish color. Okay, will change into brownish color, and also you'll get the smell, color, and you may write down very, like, strong gas. Okay, that is called pungent smell. Okay, a pungent smell comes out of this chemical reaction. So that is what you should write here. Okay, so brown color, okay, brownish color, and it gives the pungent smell. Now, have you noticed the green color of the ferrous sulfate? Yeah, it's a green color has changed. So what happened? Green color, when you have heated, change into brown. You can also smell the characteristics order of burning sulfur. Okay, so even burning, when you sulfur, the sulfur, sulfuric acid, right? So it also gives, like, the strong, very strong smell. Okay, so that smell is called pungent. Same smell will come, the strongness also comes from this gas. Okay, when we burn this. Okay, fine. Now the chemical reaction is given. What are we taking? Ferrous sulfate, which is in light green color. So what are we doing? We are heating it in a test tube. So it gives ferric oxide, Fe2O3 solid, plus sulfur dioxide. Okay, no doubt. Sulfur dioxide. It is given already here in this paragraph. Sulfur dioxide. Di means two. Okay, oxygen is two. So that means sulfur dioxide means two oxygen atoms are present. So that is why we use di. And then plus sulfur trioxide. Tri means three. Three. Oxide means oxygen. Three oxygen atoms are present. So this is what comes in the reaction. And ferric oxide is a solid. Ferric oxide, brown color. So it will be in brownish color, and you see the crystals there in the test tube, and they are solid in state. Okay, and also it gives this sulfur dioxide and sulfur trioxide. That is the reason it gives a strong uh, gas. Okay, strong gas. We call it as a pungent smell, which gives a pungent smell in this reaction. So what is happening? See here. Now you remember AB. Okay, AB or ABC gives rise to A plus, B plus, C. Understood this hint? Now see AB. How many atoms are there? Iron Fe1, sulfur 1, oxygen 1. Total 3. Total 3. It is a compound. After heating, okay, decompose, na, divide. To divide, we are heating. So 1, let us consider this as A, B, C. So when one single product divides into three reactants or three simple compounds or elements, it is known as example of decomposition reaction. So what is the ferrous sulfate formula? FeSO4. Okay, this is not comma, it is dot 7H2O. This is the formula. So when you burn this, when you do this activity, that light is green, you will find the water droplet, water moisture also forms on the test tube, in the inside, on the surface, on the glass test tube, because it's a crystal which contain water also in it, and it lose that water when you are heating it, and the color changes into brown. It is then decomposed into ferric oxide, sulfur dioxide, and sulfur trioxide. So ferric oxide is a solid, while SO2, SO3, sulfur dioxide and trioxide, sulfur trioxide are the gases. And decomposition of calcium carbonate. Okay, calcium carbonate decomposition, CaCO3. If you heat this calcium carbonate, it gives calcium oxide and carbon dioxide. On heating, it is also important decomposition reaction used in various industries. So calcium oxide is also called as quicklime, lime or quicklime, calcium oxide. Already we have learned that in the previous topic. It has many uses. So what are the uses? It is also used in manufacturing of cement. Very, very important. So all this comes under MCQs. So that is the reason why I'm explaining each and every line, because in CBSE board exam, question can be framed even from any sentence, okay, any paragraph. So calcium oxide, quicklime, where do we use? Many uses. One of the uses manufacturing in cement. Okay, manufacturing cement, we use calcium oxide. When a decomposition reaction is carried out by heating, so it is called thermal decomposition. So what is happening when is carrying out by heating? So it is dividing, right, and giving out the heat energy. So that is why it is called thermal decomposition. So decomposition means division is happening, dividing. It is dividing is happening only because we are giving the heat energy. So that is why it is called as thermal decomposition. And above the arrow, if you see, we have mentioned the condition also. If you do not use heat, then it won't be divided into, or it don't get decomposed. So that is why it is mandatory. So we write it on the above the arrow. So limestone, okay, it is also called as quicklime. Oh, sorry, it is also called as calcium carbonate. Calcium carbonate, when you heat it, it gives the calcium oxide plus carbon dioxide gas. Okay, so that is the chemical equation which is given. Now another activity 1.6. This activity also, the video has been uploaded, like in the description. Okay, so heating of lead nitrate and emission of nitrogen dioxide. Okay, so let us see another example. Another activity 1.6. Take 2 grams of, what is he saying? Take 2 grams of lead nitrate lead nitrate powder in a boiling tube. How much? 2 grams. So lead nitrate. Okay. And then what is he saying? Take 2 grams of lead nitrate powder in a boiling tube, and after that hold the boiling tube with pair of tongs. So these are called pair of tongs. Okay. You will find in the laboratory, and heat it over a flame. What do you observe? So what do we observe? It is we observe that a brown color fume is gas comes out of it. Which color? Brown. Okay, given. Note down the change, if any. Okay, so this brown color which comes is lead oxide. Okay, which comes is lead oxide, and also lead oxide, and also it gives the pungent smell. Same, that smell also will be very strong. Okay, of nitrogen. Why? Because it evolves the nitrogen dioxide gas. This nitrogen dioxide gas will be very strong. So, okay, so it also gives the pungent smell in this reaction. Is also example of decomposition reaction. So very, very important. So this question, like this, sorry, this equation, this chemical equation is asked in 2023 for 1 mark in MCQs, set 1 and set 3. Okay, and sometimes he will ask you to write the chemical equation of activity 1.6 also. Okay, what is the activity 1.6? Heating lead nitrate and emission of nitrogen dioxide gas. Okay, so lead nitrate, was the formula? PbNO3 NO3 2. On heating, it gives PbO, lead oxide, and it gives nitrogen dioxide, and it gives oxygen gas. Okay, very, very important reaction that you should learn it, practice it many times. Okay, now next one, activity 1.7, electrolysis of water. Okay, electrolysis of water, very, very important. And the same activity, even we have done the experiment and uploaded the same video in the description. So this activity 1.7, we will discuss in the next topic. Okay, fine. Yeah. Hello everybody. So in this video, we are going to study activity 1.8. So activity 1.7 about electrolysis of water. So that video has been made, and how to do this activity practically and show to your students also, that I have already done the video. Please watch the video, and you can use the same materials, simple materials which are available to do this experiment. Okay, fine. Now let us see activity 1.8. So in this activity 1.8, so we gonna study about endothermic reactions. As I have already explained you in the previous videos, that exothermic reactions. Exothermic means what? Exothermic, in any chemical reaction, during a chemical reaction, if heat is released, okay, if heat is liberated, okay, in any chemical reaction, if heat comes out, or heat is liberated, in that reactions are called exothermic reactions. Now, from activity 1.8 onwards, we study about endothermic reactions. Okay, endothermic reaction means what? In any chemical reaction, if heat is absorbed, or if heat is absorbed, and chemical reaction takes place. So such type of reactions are known as endothermic reactions. So here in activity 1.8, let us see. So what is happening? What are the activity is about? Take 2 grams of silver chloride. Okay. So what is the formula of silver chloride? It is already given. AgCl. Okay. So Ag is a silver, and Ag means silver and Cl chloride. So silver chloride, chlorine, in a china dish. Okay. Here we took. And what is he saying? This 2 grams actually. The color of the, he is asking what is the color of silver chloride. Okay, the color of the silver chloride will be white in color. Okay, the color is white. So if you take that silver chloride and if you put it under the sun, okay, under the sun for some time, so what happens is, under the sunlight, so heat absorbed by this silver chloride, and what happens after some time? So after some time we see that the color of the silver chloride, what is the color of the silver chloride? White. So the color becomes, okay, the color changes into gray color. Okay, you will find that it changes into gray color. So why does this happen? Because the silver chloride absorb the heat is absorbed. So such type of reaction is known as endothermic reaction. Okay, so silver chloride, so what has happened, and this is also an example of, tell me, it is also an example of decomposition reaction. Okay, decomposition. So suppose you can remember this hint, like gives rise to AB gives rise to A plus B. Okay, the compound silver chloride, after absorbing the sunlight, after absorbing the heat, when heat energy is produced are given, so it is again divided into silver solid and chlorine gas. Okay, fine. Now let us go to the next page. So then, what is the okay? So benefit. This is very important question which can be asked in MCQs. Silver bromide. So here, silver chloride, what happens? The silver chloride changes into gray color after absorbing the heat. Similarly, not only silver chloride, even silver bromide also behaves in the same way. It also absorbs the heat and changes into gray color. Now, what is the benefit of this? What is the use of this silver chloride and silver bromide? Okay, the main important, is these above chemical reactions are used in black and white photography. This is very important. So, which type of reactions are used in black and white photography, or which chemicals are used? Okay, in black and white photography, silver bromide and silver chloride. Okay, silver chloride. Okay, this is what you should remember. So this can be asked for MCQs in for 1 mark. Okay, now fine. So here, if you read this, what is he saying? What form of energy is causing this decomposition reaction? Tell me what form. So heat energy. And what is happening? Whether it is coming out or going inside, it is absorbing. So this is an example of endothermic reaction. Okay, so in any chemical reaction which heat energy is absorbed or energy is absorbed are known as endothermic reactions. Okay, fine, understood. So the next one, carry out the following activity. So what is he saying? Take 2 grams of barium hydroxide. Okay, take 2 grams of barium hydroxide. What is the formula of barium hydroxide? Ba, I'm writing here. Okay, BaOH2. Okay, he's saying take 2 grams of barium hydroxide and add, what is he saying? 1 gram of ammonium chloride. Add what? 1 gram of ammonium chloride. So the formula will be ammonium chloride. I'm writing the chemical reaction. Okay. Chemical equation here, NH4 ammonium chloride, and mix with the help of glass rod. So what happens, like, if you do this activity, you'll feel that heat is absorbed. Okay, so it is also, and test tube with your palm, and he's saying that chloride, and mix them. Okay, and mix these solutions. So what happens here? It takes the heat energy. Okay, plus heat. Then what happens is, what will you get? You will, if you do this activity and if you touch the bottom, he's saying the bottom of the test tube, you will feel warmness. Okay, so if you write the chemical equation for this, so barium hydroxide, so when and if you add ammonium chloride solution, okay, heat in the and okay, so heat is absorbed, and then it gives us barium chloride, okay, barium chloride plus ammonia, okay, barium chloride plus ammonia and water. So this is what the final result. Okay, now I think it is not balanced, so we need to balance it. Okay, so ammonia, hydrogen, three, four. Okay, so put two here. Okay, and then here, yeah, here you need to put two, and the water also four, eight. Yeah, so one more two in front of hydrogen. Okay, now this equation is balanced. Okay, fine, right. Now, so he's asking, is it? Do you feel any like any change in the temperature? Yeah, I feel the change in temperature. So why this is happening? Because here we are adding both. So we are giving the heat energy. So in this is an example of endothermic reaction. So this activity, barium hydroxide plus so ammonium chloride. So is an example of endothermic reaction. Or you can write this also, silver bromide. If you exposed to sunlight, it gives silver plus bromine gas. Okay, all these are the examples of endothermic reaction. So this can be asked even in your board exam. So this is very very important. And next one. So next question is a solution of substance X is used for whitewashing. So already we have learned. So which solution it is? So that is calcium oxide, or it is also known as what? Quicklime. Okay. So I'll write the answer here. Calcium oxide, calcium oxide, or it is also known as quicklime, and the formula is C, calcium oxide. Okay, and then so that the substance X is calcium oxide, and he is asking to write the name the substance, writes his formula. So formula also have written, and substance is calcium oxide, which we used for whitewashing. Okay, and then write the chemical reaction of reaction X in the above water. Okay, with water. Okay, this is very very important. So write, he's saying that write the reaction of the substance X named. Okay, so he's asking to write the reaction. So I'll write CaO, calcium oxide. It is in which state? Already it is there. We have studied solid state plus, and you need to add water to it. Okay, add water H2O. Okay, and water is in liquid state. So you'll get, so you'll be getting calcium hydroxide. Okay, calcium hydroxide. So it is actually subscript. You need to, okay, I'll write here calcium hydroxide, and the state, it is in which state? It is in aqueous state. Okay, because it is dissolved in water and it produces the heat. So this is an example of exothermic reaction. So I'll write two here. Okay, even these two also under subscript. Okay, so this calcium hydroxide. So name the reaction. Okay, this is a reaction CaO plus H2O gives rise to CaOH. Okay, twice. Okay, CaOH2, and above with the water. So this is called as slaked lime. We call it as slaked lime. Okay, the reaction which we have already studied. Okay, now why is the amount of gas collected in one of the test tubes in activity 1.7? So what is activity 1.7? Next question. It is electrolysis of water. So he's saying that why the amount of gas collected is double the amount of other. Name this gas. So which gas it is? So which is the activity? Tell me which activity. The activity is electrolysis of water. Electrolysis of water. Okay, electrolysis of water. And what are the gases collected? Tell me the gases which are collected. You watch the video also, please. Okay, gases are collected at where? Tell me. Collected at anode, and another gas collected at the cathode. Okay, so now he's asking why one gas is double the other. Okay, suppose if you write the reaction, chemical reaction. Okay, so what are we taking? We are taking water in it, right? So H2O. The formula is H2O. Okay, I'll write H2O. So what happens? So when H2O under, okay, H2O, when you give electricity, under the passage of electricity, when you pass electricity, so this is the answer for second one, okay? Second answer, this question. So let me write, you'll get hydrogen plus oxygen, okay? Hydrogen plus oxygen gas, they are collected, okay? So which gas? So at cathode, at anode, okay? At anode, oxygen gas is collected, and at cathode, hydrogen gas. Now he's asking. So we observe that hydrogen gas will be more. Okay. So H2O gives rise to hydrogen plus oxygen. Now, if you observe here, is it balanced? No, it is not balanced. So hydrogen is 2, here 2, right side. But oxygen are 2 atoms, here only 1. So put 2 here. Now, how many hydrogen atoms have become? So hydrogen 4. So it is 2 only. So then put one more 2 here. And oxygen 2, 2 balance. Now, if you observe, the amount of hydrogen atoms have been increased when you pass the electricity. Okay, so 4 atoms of hydrogen and 2 atoms of oxygen. So that is the reason why the amount of hydrogen gas will be more at the cathode. So this is what you should write the answer. You should write the answer for the second one. This is also an important question which may be asked during even in your board exam. Okay. Now let us see the next activity is displacement reaction. Okay, displacement reaction. So again, a simple trick you can remember: A plus BC gives rise to AC plus B. Okay, AC plus B. Now here what happens? B is displaced. Displaced means change the place, and it joined with A. And what happened? Like, oh, sorry, C is displaced and joined with the A, and B was removed from the compound. So this is an example of displacement reaction. Okay, so displacement, there are four types of reactions. Okay, so this is a displacement, and after that we study about double displacement. So here, if you observe, if you consider A as one atom, B as another atom, C as another atom, total how many atoms are there? 3 atoms. Okay, and if you observe how many atoms displaced, only C, that is one. So if only one single atom displaced in any chemical reaction, that is called single displacement reaction. So it is also known as single displacement reaction. So he is asking, let us do activity 1.9. So this activity 1.9, I have already made the experiment, okay, and I'll upload it in the I'll give in the description. So please watch the video so that you can understand it better. Okay, so activity 1.9 I have already explained you. Now if you observe here, so what are we taking in this activity? We are taking iron. So iron is in solid state, and we are adding copper sulfate. Okay, the copper sulfate into the test tube. Okay, so copper sulfate, if you add, it will become copper sulfate solution. Okay, that is the reason we are writing it as aqueous. And then it gives iron sulfate, FeSO4 plus copper. So if I write the same with a hint like A plus B in AB form, ABC form, A plus BC gives rise to AC plus B. Okay, so what happened? B is displayed. So we can consider that B is a less reactive element or less reactive element. So here, before going to study, we should know the reactivity series. Okay. So reactivity series of metals. We study in third chapter. Okay. So I'll tell you here. So reactivity series of metals. So first, I'll start with high reactivity metals to low reactivity metals. First one is potassium, next sodium, then next calcium, then magnesium, and then aluminium. Next one is aluminium, and then after aluminium, zinc. Okay, after zinc, iron. After iron, lead, plumbum, also called plumbum, and then hydrogen. Then hydrogen is not a metal; it's a gas. Okay, so there are some exemptions. Okay, then copper, then copper, after that mercury, okay, after that mercury silver, after silver gold, after gold platinum, okay. So these are the reactivity series of metals, okay. First, if you see, so I have written from top to bottom, means high reactivity metal, so high to low, so high to low reactivity of series of metals. Now, if you observe, we have two metals here. One is iron. Okay, so iron. Where is the iron? Iron is here, and another metal, copper. Okay, sulfur and oxygen are gases. So copper is here. Now, if you observe, which is a more reactive when you compare with iron and copper, we see that iron is more reactive. So what it will do is, see, iron displaced copper. Why it has displaced copper? Because copper is a less reactive metal. So it displaced copper and iron occupied sulfur and oxygen, or iron is reacting with sulfur and oxygen. So and it forms iron sulfate. Similarly, another example is also given here, zinc plus copper sulfate. So if you see here, where is zinc? Zinc is here and copper is here. So from these two, which is more reactive? Zinc is more reactive. So what zinc will do? Zinc displace this copper again. So zinc displaced copper and zinc is reacting with sulfur and oxygen. So it has formed the sulfur zinc sulfate. Next one is lead. Okay, lead and copper. Now tell me which is the more reactive again? Lead is more reactive. Okay, so lead displaced copper again, and it formed lead chloride. So these are the some more examples of single displacement reactions. Okay, so we should know about reactivity series of metals. Okay, so the most reactive is potassium, sodium, calcium, magnesium, okay, aluminum, zinc, iron, lead, hydrogen, copper, okay, copper, mercury, silver, gold, and platinum. Okay, so this is about single displacement reaction, and this activity 1.9 I have already made a video. Please watch the video. Okay, and then after that another experiment, double displacement reaction. Okay, so here you can remember in this way, in ABCD form, AB plus CD. Okay, so let us have AB is a compound, CD is a compound. Okay, and A is a atom, B atom, C atom, D atom. So now, if you write like this, AC plus BD. So what happened here? So C displaced and reacting with A, B displaced and reacting with D. So this is called. So how many atoms are being displaced? How many elements? Okay, two. So if two or more elements or two or more atoms get displaced in any chemical reaction, that is called as double displacement reaction. Okay. So this activity also I have made the video. So you may watch the video which been uploaded in the description. Okay. So here take about. So what is this activity? Take about 3 ml of sodium sulfate solution. Okay. Sodium sulfate. So what is the formula? Na2SO4. Very, very important. Okay, you need to underline each and every formula and you need to practice it. And what will be the color of this sodium sulfate salt? Tell me. The color will be white color. Okay, so here double in this reaction, it is a precipitate reaction. It is also known as precipitate reaction. Okay, fine. Now, and he's saying that in another test tube, take 3 ml of barium chloride. Okay, barium, this is a chemical formula. What will be the color of barium chloride? Again, barium chloride also will be in white color. Okay, barium chloride also will be in white color. And then, so if you do this activity, so what will happen is here, if you observe sodium, okay, sodium and sulfur oxygen and barium chloride. So barium displaced sodium, okay, barium displaced sodium, and after that barium formed barium sulfate and chlorine, okay, and sodium chloride salt, sodium chloride, and Na is reacting with chlorine, and it formed the sodium chloride, so barium sulfate. So how many elements got displaced here? Two. So this is an example of double displacement reaction. Okay. Suppose if it is asked in exam that give some more example, you can write. So you can write one more example. I'll give you here. So silver nitrate, AgNO3, silver nitrate. Okay, it is a substrate actually. Okay, uh, which will be dissolved in water, aqueous. plus, if you add salt, sodium chloride, salt, okay, salt, then you will get silver chloride, AgCl, okay, silver chloride. Here you will find this silver chloride precipitate forms, okay, silver chloride plus sodium nitrate, NO3, okay, NO3. So this is what you'll get, and here it is a precipitate reaction. So I'll put an arrow down. So this is also even in this equation also, if you see, so two elements got displaced. So another example of double displacement reaction, and precipitate is formed. So we put an arrow down. Okay. So this is all about activity 1.10 double displacement reaction, and then he is asking recall activity 1.2, okay, where you have mixed the solution lead 2 nitrate and potassium iodide. And what is the color of precipitate formed? So okay, you see the color will be yellow. That also I had made the video. Please watch the videos. Okay, watch the video, then you will understand, and try to answer the questions which are given in this page. Okay, and next one, oxidation and reduction reaction. Okay, so oxidation reduction reaction, I have made a simple video, very simple video. Okay, a trick to remember oxidation and reduction. What is oxidation, what is reduction, by using AR Rahman. Okay, that trick I have made, and that video also uploaded. You please watch that video. So here if you observe this activity, I'll just explain you. He's saying that take copper powder. What is the color of the copper? Tell me. The copper powder will be in the brown color. Okay, and then and take it in a china dish, 1 gram of copper powder, and heat it. What do you observe? When you heat this copper powder, brown color changes into black color. Okay, it changes into black color. Okay, and then he's saying if you pass the hydrogen gas, so now let us see that, let us assume that this is a copper powder which turned into black color after heating. Now he's saying that now pass hydrogen gas through it. Okay, pass hydrogen gas to it. Okay, and then what happens, then the color of the, then color changes again, it come back to the same color, brown color. Okay, so here we are giving heat energy, absorbing it, absorb heat energy. So again, this is an example of endothermic reaction. So these are called reverse reactions. Reverse reactions. Okay. So copper, when you heat it, so oxygen is merged under the presence of oxygen. It forms copper oxide. What is the color? Black color. And then the same copper oxide, if you pass hydrogen gas to it, okay, and then again it come back, again it form copper and plus water also. Okay, water moisture. So this is a reversible reactions. Okay, so this is a about activity 1.2.5. Okay, and here few equations are given. So he's asking to find what is oxidation, what is reduction. Okay, what is oxidation? Tell me. Oxidation is nothing but gaining of oxygen. So here if you observe, hydrogen do not have oxygen, so it gained oxygen, so it is called oxidation. So copper has oxygen, so it lost the oxygen, so it is called reduction. So what is oxidation? I'll write here. So oxidation means gain of oxygen or lose of hydrogen. This is called oxidation reaction, lose of hydrogen. Then reduction reaction. What is reduction reaction? Gain of hydrogen. Okay, gain of hydrogen or lose of oxygen. So this is called reduction reaction. Okay, so he is asking to find out which is oxidation and which is a reduction. So you need to write here. Okay, try this. Okay, any doubt if you have, you may put the query in the description box. Okay, and last topic. So with this chapter will be concluded. And now he's asking, in reaction 1.31, carbon is oxidized, means carbon gain the oxygen, and zinc it is reduced to zinc. So it is called as reduction reaction. Okay, so this is the definition he has given here. Okay, so simple trick also I made, oxidation reduction using AR Rahman. Okay, please watch that video, you will understand it better. Now, recall again. We recall activity 1.1. What is activity 1.1? Activity 1.1 is nothing but burning off a magnesium ribbon. This activity also I made. I uploaded the video. Please watch it. Okay. So what happened? Magnesium being oxidized or reduced in this reaction is asking. When you are heating it, is it oxidizing or reducing? So that also is asking. So you try to answer this question. Okay. After watching the video. Fine. Now, have you observed the effects of oxidation reactions in daily life? Okay. Have you observed the effects of oxidation reactions in the daily life? Oxidation means what? Gaining of oxygen, gaining of water moisture. So what happens? So if any substance gain oxygen, it will get corrosion. Okay, or rancidity. So rancidity and corrosion, what is the difference? See, corrosion means suppose if you exposed any metal objects to the any metal object, suppose iron nail, if it is exposed to the moisture, to the atmosphere, what happens? It changes into its color becomes dull. It changes into brown color. So because a layer of oxide, okay, because the copper, if you it reacts with oxygen, it forms a copper oxide. So that is called corrosion. Okay, suppose if silver oxide. Okay, so all these are the effects of oxidation in the daily life. So why the iron nail gets the color changed because of that only. Okay, suppose if copper reacted, the color it changes into light green color. Okay, so all why this been happen? Because they are exposed to the oxygen, they are getting oxidized. Okay, so what are the effects of those oxidation? If they get oxidized, their strength become weak. You can easily break the iron nail. The strength of the metal becomes weak. Okay, so these are the effects of oxidation. So one is corrosion. Corrosion means what? Corrosion means forming a layer on the above the surface of the metal. Okay, when they expose to the moisture or oxygen. Next, what about rancidity? Rancidity means change in smell and taste. Okay, so rancidity means change in smell or the taste. This is the about rancidity. So what happens when can we see a smell change in taste? Suppose any oily item. Suppose let us take chips. Chips. Suppose if you take chips or kurkure, when if you expose it in an open air, what happened? It gives a smell changes. Smell changes and taste also changes. Taste also changes. So that is called rancidity. So then what will you do? How will you preserve those substances which which are made up of oil and exposed to oxygen to save them from smell changes and taste changes. You need to use the tight containers. Okay, we will use the tight containers like what we do. Suppose if you are preserving the pickles, okay, pickles, we keep them in a tight containers, right? And also chips and or kurkure, whatever, which are made up of the potato chips are oily packets. So what we do, so if you I think you might have seen the chips packet is filled with some air, right, some gas. So that gas is called nitrogen. So which gas they use? They use nitrogen gas. Why? Otherwise what will happen? The chips get oxidized and the chips, become very the smell changes states, won't be crispy. Okay, it won't be crispy. So to protect those oily items which are you made up of oil, and they will be preserved in a tight containers, as well as, and they will be preserved under the nitrogen gas. So very important topic. So how to protect the oily food items? So one is storing them in a tight containers, put materials in a tight containers, and also by filling it them with the nitrogen gas. Why? To prevent them to react with oxygen getting oxidized. So this is all about rancidity. Okay, so these question and answers, now I think this chapter is completed. Only few question and answers are given in this page, and briefly explain you why did the color of the copper sulfate changes? Okay, copper changes when iron nail is dipped into it. Okay, write down the answer. Okay, please note down the answer. Because so iron is more reactive element. Okay, reactive metal, more reactive than what? Than copper. Okay, iron is more reactive than copper. Okay, I'm writing the answers here. This is the first answer. Iron is more reactive than copper. And what happened then? It displaces copper and displaces displaces it from where? From copper oxide. Sorry, from copper sulfate. Sulfate. Okay, so that is the reason the color changes. Copper sulfate. Okay, and what happened as a result? You may write down the answer. As a result, copper is copper is deposited where? Deposited, and ferrous ferrous sulfate is formed. Okay, ferrous sulfate is formed, and what is the color? Which is in light green color. Understood? I hope you understood. Light green color. Okay, so that is why the color been changed, and also you may write the color also. Okay, you should write the color as well. And what was the color compared to previous color, compared to dark blue color of copper copper sulfate. Okay, this will be the answer for first one. And also give an example of double displacement reaction other than given in activity 1.1.10. So he's asking to write, give a double displacement reaction. Any other example? Okay. So there are many examples that he's asking that instead of writing which is given in 1.10. Okay, sodium sulfate. He's asking to write another double displacement reaction. So which one you may write? You may write this chemical reaction. Okay, iron. Okay, plus copper. So this I'm writing. Okay. Sorry, this is not for second one. This is for this one. Okay, the first one only. Chemical reaction. I'm chemical equation. I'm writing copper sulfate. Okay, 4 is a subscript. Okay, so FeSO4 plus copper. Okay, this reaction is already given. And second answer is asking to write the equation for double displacement reaction. You may write lead nitrate. I think you remember it. Okay, lead nitrate NO3 which is in solid state, plus potassium iodide. Okay, I am writing the balanced equation, okay, which I have already explained and given even in your textbook as well. Okay, what it forms? It forms lead iodide. Okay, lead iodide, which is in solid state. Okay, plus potassium nitrate. Okay, aqueous lead iodide, which is in aqueous state. Okay, so I'll just correct it here. So what will be the correction? They are the subscript. Okay, here you should write 3 here and 2 also small. Okay, this 2 also here and 3 here. This is the example. This is the answer for second one. Okay, and now third one. So he's asking, identify the substances that are oxidized and which are reduced. So here just we need to identify. See here, sodium gained oxygen, so we write it at, we just put an arrow and we mention here oxidation. Okay, and here if you observe, copper lost the oxygen, right? It lose the oxygen, so we'll put an arrow and we write here reduction. Okay, so it is reduction. So this is all about this chapter. Okay, I hope you all have understood. If any doubts if you have, you put please put comment in the comment box, and the answers for this whole chapter I'll upload another video. So with that we'll conclude this. chapter. Okay, thank you everybody, and I hope you have understood. So very important that um, you should read each and every every sentence and underline and make your own notes. Okay, and whatever the chemical equations and reactions which has been given in this chapter, you need to practice them more, and then you'll definitely get out of marks from this chapter in the board exams. Okay, thank you everyone.